Test, all right. Hello, everyone. I am thrilled to be here at this conference sponsored by my favorite group in tech, UtahJS. I owe this community so much, and I'm so excited for the opportunity to contribute to this experience. My name, as Tanner said, is Drew Warren, and my talk is titled Framework Free, Functional HTML Rendering, and State Management in Vanilla JS. So if you're looking for advice on optimizing your Angular app, you're in the wrong theater. That kind of falls flat because that talk got canceled, but... If you want to hear about how your habits and prejudice might be getting in the way of your engagement with JavaScript, then stick around and I'll try to keep you entertained for the next half hour. So this is my face, this is my Twitter handle, this is my username on the UtahJS Slack org. Is anyone here not in the UtahJS Slack group? Okay, go to slack.utahjs.com, put in your email, and join. You will not regret it. You'll get help with your code, advice on interviewing and comp negotiation. You'll find invaluable resources on specific subsections in our countless channels. You will level up just from lurking and might even find some friends. It's amazing. Like I've said before, I owe this community so much, and I'm always looking for a way to give back. So please, @ me, slide into my DMs, start a thread in the accessibility channel, and I'll be in touch. Before we get into the meat and potatoes of my talk, I wanted to preface this by saying I am not an expert. There's a reason why you don't already follow me on Twitter, but those notifications are coming in. Thanks, guys. There's a reason why I applied to speak in the beginner track for this conference. I'm a bit of a late bloomer, 32, without a CS degree, and I learned by doing. I've only been doing this for about 3 years. So I still have a lot to learn, and I may get some things wrong. I just respectfully ask that if you do hear me say something that is untrue or misleading, please point it out to me, but do it after the talk. Hit me up on Twitter or Slack, and I'll make sure to improve my presentation and make the correction public. Thank you. So this is a talk about using DOM APIs exposed to JavaScript to manipulate elements on a web page without having to write any HTML. We're going to learn how index.html can be a blank canvas, and we can create nodes, append children, remove nodes, update properties, attach event listeners, and apply styles all through vanilla JavaScript. We're going to talk about single-page apps, functional programming, higher-order functions, and state management. And we're going to look at some examples in code that I promise you will understand, and you'll even be able to use them without any configuration or setup. It's going to be rad. So who will benefit from this talk? I hope everyone here learns at least something, but I do have two specific groups in mind. The first group of folks, perhaps you're self-taught or hobbyist or some diehard JS fanatic who shivers when he hears the word ECMAScript and thinks the language peaked in 2015. You folks are either resisting frameworks intentionally or you're intimidated by the learning curve. Maybe you gave it a shot and it just didn't click. So I'm hoping that some of the principles I discuss will help you think about how to leverage JavaScript to make a modern web experience that can segue into the proper framework when the problem you want to solve is complex. The second group has been growing exponentially over the past 3 years since I've gotten into the game, especially here in Salt Lake City, and these are bootcamp grads. Some of these people spent about 2 weeks, maybe 3, learning JavaScript before just diving right into a framework and never looked back. So I hope this talk will show you that a lot of your favorite things from React, Angular, and Vue can be accomplished without those tools. You may be using a sledgehammer to drive a thumbtack. When I graduated from a dev bootcamp about 3 years ago, this was me, and I was very guilty of this, and that's actually what led to this talk in the first place. Speaking of hammers, there's an idea called Maslow's hammer, and you'll hear it often said as, if all you have is a hammer, everything looks like a nail. And this is a mindset that people get stuck in when, they know React, they love React. First thing they do is reach for Create React App, and every problem is solved with React, whether it needs to be or not. So I'm hoping if your sites are low and you aren't even looking at frameworks, or if your sites are high that you're not even really writing JavaScript anymore, maybe we can meet in the middle and learn the pros and cons. So like I said, I want everyone to learn something. So if you know more about JavaScript than I do, that might not be true. So hopefully here's a few accessibility tips. That's what I do mostly at my job that maybe you can take away, if nothing else, at least a few things. So number one, don't convey information with only color. As you can see here, I've highlighted my title in orange. Or maybe you can't see that because you suffer from achromatopsia, severe color blindness where you only see black, white, and gray. So I've underlined the text here to signify the highlight. I want to take a few minutes to establish some vocabulary and give context into what I mean with the title of my talk. First, what do I mean when I say framework free? What is a framework? Wikipedia says a web framework is a software framework that is designed to support the development of web applications. Web frameworks provide a standard way to build and deploy web apps on the World Wide Web, and they're aimed to automate the overhead associated with common activities performed in web development. Examples include jQuery, Backbone, AngularJS, Angular, Ember.js, React.js, and Vue. And if you're a JavaScript developer, you know since I started this talk, we've probably popped out a few more. I can already hear some of you muttering under your breath, well, React isn't a framework, or jQuery is a fast, small, and feature-rich JavaScript library. But for the purposes of this talk, the terms library and framework are going to be synonymous. After my research and the differences between the two, I have yet to find a set of definitions that has provided me with any real value outside of pedantics. So we're just going to ignore them. For the next little bit, let's think about it this way. If you're importing someone else's code, and that's making you write your code in a way that isn't valid JavaScript that runs in the browser, you're using a framework. So what is functional HTML rendering? Simply put, we're going to use functional programming techniques with JavaScript to render HTML elements. So what is functional programming? Well, I don't have the time or necessarily the expertise to fully explain the ins and outs of FP, but I will try to explain a few of the important principles and see how we can take advantage of them. First is the concept of a pure function. A pure function is one that, given the same input, will always return the same output and also produce no side effects. Second is composition. Composition is the act of combining small methods into a larger task. We create specialized functions that do one thing, then we can string them together or pass them into each other to accomplish more complex tasks. And last is immutability. Immutability is the idea of not changing the contents of a variable once it has been created. A common technique to achieve immutability is that instead of changing a variable, we'll create a new variable and assign to it the work we've done on the starting variable. So that's my 30-second lesson on functional programming. I highly encourage you to build something with a functional programming language, because I think that is the best way to understand the paradigm, and the lessons you'll learn while you're learning that will make you a better JavaScript developer. So finally, vanilla JS. Why not chocolate? For the purpose of this talk, vanilla JS means JavaScript that can be run in any major browser with no compiling or importing. I know that we engineers tend to be a bit pedantic, and while this trait is not my wife's favorite of mine, I believe that in order to understand each other, we do have to say what we mean. So I want to be very clear for the pedants in the crowd. The DOM APIs we're discussing are not JavaScript. The DOM was designed to be agnostic of any one programming language. And similarly, JavaScript is not limited to only running in the browser. And this is how we have server-side JavaScript with Node and other things. But it is in the web browsers that we are able to directly access DOM APIs using JavaScript. The browser will parse HTML text into nodes and objects called the document object model, or the DOM, so programming languages can connect to the page. So when we call document.createElement, we're using a JavaScript method supported by the browser to access the DOM API. And a quick disclaimer, the DOM is inherently object-oriented, document object model. So unfortunately, we're going to break some of the rules that I just laid out with functional programming, but we're going to do the best that we can. So again, vanilla JavaScript just means JavaScript that runs in any major browser without a build step, compiler, Webpack, Babel, none of that. So one last thing, and we'll start looking at some code, single-page applications versus multiple-page applications. I'm sure most of you have heard of a single-page app, but it's important to understand the concept with regards to functionally rendered HTML. A single-page app is just that, an application that exists on a single page. You have one HTML file, and rather than routing to multiple HTML files, you use JavaScript to update the HTML. One of the benefits is that all of the resources of an app can be loaded just once on the initial load. Further actions of the user won't trigger another load. Once a SPA is loaded, you can theoretically disconnect from the internet and continue to use the application to go from view to view. This does lead to a longer initial load time, which is a trade-off. Some other trade-offs can come in the form of SEO or search engine optimization, browser history behavior, like whether your back button does anything, And of course, if a user has JavaScript disabled, your app's just not going to work. There are some workarounds. You can use meta tags to help with SEO, URL parameter manipulation if you want the back button to work, and a no script tag to try to at least show your user, hey, you should enable JavaScript. And these are all just some things to consider before deciding whether an SPA is the right choice for your app. But if it is, let's talk about how to make one with vanilla.js. So first, we need to build our blank canvas. As you can see here, we've got a nearly empty HTML file. Title, a link to a style sheet, a script to load our JavaScript, and an empty body tag. I've given it an ID of app, but as you can see, it's self-closing with no content, completely blank. You guys are obviously not as excited about this as I am. I mean, I'm really starting to sweat looking at this. It is so beautiful. Why? Well, if you can't feel it, then that probably means you've not recently written 100 lines of HTML, and then rewritten those hundreds of lines of HTML, and then hunted through 100 lines of HTML to make an update on HTML element by element, making slight updates. So just looking at this, you can already tell you're never going to have to do that, which is great, right? I mean, we're not at UtahHTML Conf, we're JavaScript developers. This is awesome. So we've got a blank canvas, and now we want to put something on there. As with most things in development, there are many ways to get this done, but here are just two to wet your whistle. Not shown, but I functionally added a container div with the class JSHelloContainer, so you'll see me targeting that here. In the first function, we're going to call querySelector to target this container div by its class name and set it to a variable. Then we'll call document.createElement to create a paragraph element and set that to a variable. Next, we set the class name property of the element. This lets us add a class. This is not functional programming. We're changing the variable, sorry. Class is a reserved keyword in JavaScript, which is why the property is called class name. After that, we call createTextNode function. Hold on. This is going to return a text node. I know. It's really, you guys are brilliant if you're following me so far. Penultimately, we append our text node to our paragraph element, and then finally, we append our paragraph element to our container using the element's appendChild methods. A few things to note here. The createElement function will take any HTML element as its first argument. We're using a P, you can use a div, article. If it's HTML, it'll fit in there. And there's an optional second argument, but it's not supported in Internet Explorer, so we're not going to go into that. Okay, I was expecting groans, but the fact is, in June 2019, Internet Explorer accounted for at least 5% and up to 14%, depending on what metrics you look at, of desktop browser traffic, and I'm personally not interested in ignoring those people, so I'm considering it a major browser. Looking forward to the day when that's no longer the case, as I'm sure we all are, yes. In the second function, we take a different approach. We create the element as a blank div, and then we use the outer HTML property to more or less completely rewrite it. So there's an inner HTML property, which you can think of as the stuff between the closing and ending tag, which is great for something like adding a text node. On the other hand, outer HTML is the stuff in between and including the tag. So it's a one-stop shop for applying an ID, a class, event handlers, data attributes. We'll set the tags themselves as well as anything inside them. So any valid HTML string in the second to last line can be used with outer HTML. Here, I'm transforming an empty div to a heading level 1 with a class name and some text content. And finally, I append that to my container. So now we've got some HTML, great, but our user wants to visit another page, and we can't just keep appending children and tacking stuff onto the bottom, so we need to clean up our mess and start fresh. We start by grabbing a reference to the element we want to remove the contents of. Here, I've chosen my hello container, but you can target the whole body, an ID, class name, again, whatever you can find with your document query selector or other methods. The easiest way is just to set the inner HTML to an empty string. So that'll take everything in between your starting and closing tag and make it disappear. However, there is another way to accomplish this, seen in the while loop in my first function, fast goodbye versus slower goodbye. This loop looks for the first child of our targeted element, and as long as it finds one, it will call remove child. So I haven't found a resource that tells me why this first function is so much faster, but I have found several performance measurements that show it is to the tune of about 80%. So if you know why this is, Slack me, tweet me, and let me know. I will tell you all. I'm sorry I can't fill that in. So we're adding elements, we're removing elements, but this doesn't look any better than writing raw HTML. You're sitting there asking yourself, why the heck would I write 3 or 4 functions to get a single line of HTML? So here's where composition comes back into play. We've got our function that does one thing. It gives us an HTML element. Well, instead of one string, we want to show, what if we have an array of strings? We can pass our functions into a higher order function, like the map method available on arrays, to return an HTML element for each value in the array. So here, instead of making one line with 3 functions, we're making 4 elements by writing 4 functions. What if we want 40 elements? How about 400? Did you know that there are roughly 6,500 spoken languages in the world today? You can render hello world and all of them with these 4 functions. So I hope you're not asking yourself, why would you want to do this anymore? So let's say we have our 6,500 greetings, and instead of divs, we want them rendered as LI elements. We just got back from a talk about accessibility. We learned that semantic HTML is important for users who depend on screen readers, and that semantic HTML elements come with all sorts of accessibility benefits right out of the box. That's accessibility tip number 2, by the way. So here, all we do, we change our container to a UL, and then change the one parameter div to LI, 6,500 lines of HTML written with one small change in your code. Easy, right? So I'm not going to spend too much time here, but I don't want to leave anyone behind. So if you haven't used map off of an array before, or if you heard me say higher order function and you thought, Pikachu what face.jpg, then let's catch you up real quick. So at its core, a higher order function is one that takes a function as a parameter. This parameter function is often referred to as a callback. You can build your own higher order functions to do all sorts of wonderful things like piping, mapping, flat mapping, all sorts of combinators that will blow your mind. Seriously, functional programming just scrambles my brain every time I look at it. One of my favorites is to take an array of objects and then return an object whose keys are a value from the object, like an ID, and then the value is the objects themselves. This is often called a dictionary because it lets you easily look up objects with something like the ID. Looking up stuff in the dictionary, I think that's why they call it that. So there are a few that are natively included in JavaScript as array methods, demonstrated here: map, filter, and reduce. My favorite explanation of these is in this nifty graphic from an article on a10designgroup.com. Map, first, will take an array of values and give you a new array of the same length with some action being performed on each value, like taking an apple and giving you a slice of an apple, or taking a string and giving you an HTML element wrapping the string. Filter will take an array and give you a new array of objects that pass a certain Boolean check, like taking an apple, an orange, and a banana and giving you back just those that are an apple, or taking an array of greeting strings and giving you just the ones that are hello. Reduce will take an array and give you something new by performing an action on each item, like taking 3 fruits and returning 1 fruit salad, or turning an array of objects into a dictionary. Higher order functions are really the bread and butter of taking data structures and returning HTML. You know this if you're using React in production like I do, these functions all day long. So at this point, I may have said the word render about a half a dozen times, so I figure we should probably talk about that. The Oxford Dictionary will give you the following definition for the word: to cause, to be, or become, to make. So what is a render function? A render function is a function you can call that will cause your app to be or become in another state. It will make your application. In this example, my render function is the show page 1 function at the bottom. It will clear the contents of the app and then return a header, as you can see defined above, and then return the contents of the page. So what does a render function require? Well, if it's going to make your app, then it needs to understand the state of your app to know what to cause your app to be or become. Application state can be tough to define without breaking the taboo of defining something by using the word in the definition. I can stand up here and say application state is the state of your application. And we can all stroke our chins and nod our heads and say, indeed, because it seems self-evident. But I'll take a stab at doing something a little bit better. Application state is the information necessary for your render process to display the proper elements with the proper attributes. I think that's pretty good. So using that definition, we can manage state in a couple of different ways, but you better believe they're all going to involve functions. The more complex the app, the more functions your renderer is going to have to call to display the proper elements with the proper attributes. We can do this statically, like in my show page one function here. No matter where you are when you call this function, you're going to get your header and the page one contents. Or we can do it dynamically by passing in state, like in this render function. So again, we'll clear the page, and then we'll call a layout that will look at the piece of state to determine the layout, and then the contents similarly, and finally the progress. So state is great, but the internet by default is stateless. So how do we handle that? We need to store our state somewhere we can access after our session. To really have some permanence, we'd want to store this in a database. But if the application isn't so important that losing the state is going to have a severe negative impact on our user, we can just use local storage. Local storage will let us cache information in the browser and access it at a later point. Since I'm storing an object and local storage only stores strings, I'm using some JSON APIs to stringify and parse the object. So in this example, I have an initial state in case the user has either purposefully or accidentally cleared their local storage. And then when I increment the slide, I create a new object that looks like my state with an update. And then I call object.assign to apply that to the starting state, changing the fields that are present in my updated state. So it's important to note here, I did not mutate the state object that I got. I created a new object. If I were to console log my starting state right before this return, it would look the same at the end of the function as it does at the beginning, but I get a new state that I can set to local storage. So that's the immutability. Quick accessibility tip number 3, if you have an animation on your page, you should be aware some users can suffer from seizures or migraines from too much change in color or movement on a page. So you don't want to autoplay these, but if you do, you want to also either auto-stop them or give the user a way to stop the animation themselves. So here I've made some GIFs with GIFFox, and my GIFFox GIFs will play 3 times and then stop. So now we know how to use vanilla.js to make a spa. But why? Was this purely an academic endeavor? Did our quest to find out if we could eclipse our responsibility to ask if we should? No. There are some objective benefits as well as some subjective ones that you'll get if you go framework free. First, errors. I know this text is really small, so I'll just read it out to you. We'll compare the console errors we get when we try to reference an undefined variable in JavaScript versus in React.js. We see at the top, we have 3 lines. The line where the error occurred, the function that called it, the function that called that, and then the line that that function was defined on. If you have experience with React, I'm sure you've already found some useful information from this bottom 30, 40 lines of error message, but I doubt you can look me in the eye with a straight face and say you prefer this bottom content to this top one. Useful errors. The next benefit is code readability. So let's compare the source code of a hello world spa in JavaScript to one with JS. So here it is in JavaScript, again, empty body with a function that just targets the container and renders hello world. Now let's take a quick look at the source code for a React app. So again, hello world, that's all we got. Beautiful colors, I know you guys appreciate that. So we're going to go to the source and check out some of these files here. So we've got 300 lines of mush. We've got 800 lines of mush. We've got 39,000 lines. You can see that bar is not moving. I'm scrolling. All to render hello world on the page. So this here is more readable for everyone. That includes you while you're developing, contributors to your project, and anyone that finds your app. None of your function declarations are hidden in an npm modules folder. No one needs to know what version you're on. You can just check the method on MDN. If it's green, it's good. Finally, a user can actually inspect your page, look at your source, find your files. Not a minified, compiled version of your files, but your files. This could be a high school student that dreams of dabbling with development that wants to learn. This could be a potential contributor who finds a bug and shoots you the exact line number without having to first find you on GitHub. Another dev maybe likes the technique you're using and learns directly from the source how to emulate it. That's how we're going to make the world a better place, with readable, accessible, and approachable code. Another reason why you might want to do this, just so you guys know, I made this slide before I learned Tanner was going to be the MC, but there's his face. Your role models did this, probably. So these are some of my dev role models, and I asked them if they use vanilla.js before a framework. AJ is here at the conference. He said, yeah, frameworks weren't a thing. He taught me that the newest thing isn't always the better thing. Here's Tanner. He learned how to use the DOM API before JQuery. He taught me how to help other developers with open source projects. Kyle Simpson, I actually couldn't get in touch with him. His DMs are off, and Twitter. He's a really popular guy, so I don't blame him. But he did give a talk in Utah last May where he lamented about what we've lost by not being able to inspect the source anymore. When he was learning, he inspected the source. And then Kinsey Dodds, another one of our role models, didn't actually use vanilla JavaScript, but he taught me a lot of patterns for using and testing React that I applied to this talk. So these are all great guys. If you don't know any of them, look them up. So we've talked about how, we've talked about why, but when should you drop your framework in favor of vanilla.js? And I'll be 100% honest with you, maybe not all that often. If you have a complex problem, it's going to require a complex solution. If you have lots of asynchronous code, animations, shared state across different parts of your app, you will benefit tremendously from something like React, Angular, or Vue. So when would you want to do this? Maybe there's a local business that you want to help market themselves, mom and pop store that you go to and you notice their website sucks. Maybe you have an idea for a simple application that can make an impact that doesn't require complex state management. Maybe you want to make a slideshow for a conference presentation. Let's check it out. Go into my source here. You see I've got 2 JavaScript files, one with all my slides. My slides have a number, a layout, a type, and then content, which includes element types and the contents of the elements. And then my script here, DOM manipulation, some state management. You can read all of this, vanilla JavaScript. You could copy and paste any of this, put it in your code, and use it tomorrow, and an initialize function. So practicing what I preach a little bit here. I had a couple extra, thank you. I had a couple extra slides here in case I got nervous and talked too fast, but we're running low on time. So basically, the summary of those was, you want to find a way to improve the world. At least that's what I want you to do. If you're lucky, that will be your job. If you aren't so lucky and you're not finding that at your job, then it's time to start your side project. So here's a challenge for you. Don't fall into my trap. Don't sit there wishing you had React or Vue or Angular when you're starting your project. Just try it out without your favorite framework. And I want to see it. So again, UtahJS, there's a great channel called I Made a Thing. If you find a problem and you can solve it with vanilla JavaScript, just post a link in there. I'm going to come in, I'm going to inspect your source, and I'm going to see your code, and we're going to be able to talk about it without having to share a repo or anything like that. So what did I get wrong? Again, I'll have my contact information on the next slide. If I misled anyone on anything, please reach out to me, let me know. I think that sharing knowledge is noble, but sharing lies is evil. I'm not trying to do that, so point it out to me if you saw something I can improve. And then finally, I want to thank UtahJS for the chance to speak, and I want to thank all of you guys for spending the last half hour with me. I hope to hear from you soon, and I hope we can all make the world a better place together. Thank you.